Good morning, everyone. Hope all is well. Hope everyone's doing all right. Still waiting for everyone to log on or get fully connected. So let's give them a second. All right, looks like we are good to go and get rolling. So like I mentioned last class, just going to talk about a few things, nothing major today, but chapter 1 and chapter 2, are full of definitions and graphs. And you'll see with my little bit of drawings today that, graphs are not my forte as far as drawing are concerned. So, but if you have any questions on anything, always feel free to ask. Make sure you get those questions addressed, whether it be graphs or whatever the case may be. So make sure you go ahead moving forward. Um, so let's go ahead and do those few things. And then from there, we'll make sure we're clear on what you guys are here responsible for moving forward with chapter 1 and chapter 2. Hopefully, I saw that some of you got it. So hopefully everyone saw that I sent out that course ID for Math Lab. This was for 155. Yep. Make sure you guys see that course ID that I sent out. I sent the email, and like I said before, if you didn't see the email, it's always in your Canvas announcements. All right, so yeah. So, like I said, just a couple things out of chapter 2. The first thing is talking about the distribution of data and the shapes. So the first one is the bell-shaped curve. It has your mean in the middle. Hold on one second. Sorry about that. So your mean is in the middle, and it's 50% of your, it's reflected about the mean, symmetric about your mean. So you have 50% of your data on the right of your mean, 50% of your data on the left of your mean. So that's what was being said right here. It's called the normal distribution. And as I said right here, this is one that you should remember and try to hold on to, because that's the one that's going to come up. And a lot of things we're going to do is going to be dictated upon the idea that we have a normal distribution. The bulk of your data is in the middle, right where the mean is. And then as you get away from your mean, less and less of your data will be. All right. And also, when it comes to copying notes and everything, since most of everybody has their camera off, I don't know if you're done writing or you're still writing. So if I decide to scroll up to go to the next thing, but you're still copying, always feel free to either unmute and say, could you hold on 1 second, or type in the chat. I'm monitoring the chat as well. So either way, just let me know if I need to stop, go back up or something like that. All right, the next one is uniform distribution. And it's more like a block because all of your distribution is just distributed at the same level of distribution. Yes, this information will be in your textbook as well. Yep. As a matter of fact, the majority of the information that you're going to need will be in the textbook, because remember, we're not doing full lectures on chapter 1 or 2. Really, full lectures get started when we get into chapter 3, which will be on Wednesday. We're just touching on a few things, but the major things that you want to pull from chapters 1 and 2 are your definitions and the graphs and stuff like that. So. All right. So the third and fourth graphs or distribution shapes is where I want to make sure I bring clarity. So you talk about being skewed left. That means the tail of your data is to the left. So if the tail of your data is to the left, that means the bulk of your data is actually to the right. So just want to make sure we're clear on that. When your data is skewed left, it doesn't mean that it's pushed left. it means that the tail of your data would actually be to the left. And then being skewed right means the tail of your data is to the right. All right. Questions on anything before we scroll up? All right, everybody good? Of course, once again, if I scroll up too far, let me know. Okay, so the next thing here is stem leaf plot. So your leaf or your leaves will be the rightmost digit of your data value. Then your stem is going to be all the values that precede that rightmost digit. So if you look at the number 53, your leaf will be 3, and then your stem will be 5. Then for 127, your leaf would be 7, but the stem would be 12. So your stem is always going to be all of the digits that come before that rightmost digit.
So the leaf will only ever be one number, correct?
Yes.
Okay.
Mhm. All right, scrolling up some. All right, so this is the data set that we're going to convert to a stem leaf plot. My data set is in order, and I just went ahead and put it in order for board purposes. The data set doesn't necessarily have to be put in order when you first get it. We have 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and 112. I'll give you a chance to write that down. All right, so the next move to make is, notice what I have right here in the profile box. You want to establish the minimum and maximum values. So 41 is our smallest value, 112 is our maximum value. And so that means that this data set goes from the 40s to the 110s. And I'm going to erase this next stuff so we can walk through it. So we set up our stem leaf plot this way. Notice we go from the 40s to the 110s. So that's, excuse me, that's why our stems are set up this way. All right. So then from there, we go ahead and write down each leaf that represent each data value that we see. So we have 41, so I'll put a 1 right here beside the 4. There's nothing up for the 40s. So I go to the 50s. So there's 50 and then 56. Now there's no data value for the 60. So what I do not do is put a zero here because that would represent the number 60. I would just leave it blank. And then go to 70s. I have 71, 72, 72, 75. So 72 appears twice. So I'll write the number 2 twice. All right. Any questions as I continue to put in our values?
So even though there's no 60 digits, the 60s, you still have to put it in.
Well, yeah, you'll put it in as a stem, but you wouldn't put anything in there for the leaf.
Copy.
All right. So we got 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93.
I have a question.
Yes.
Since 60 is blank, how come for 50 and 80 you have to put the zeros down?
Oh, that's because we had the number 50 and then the numbers 80. So that represents 50.
Oh, it wasn't there. Okay, I got what you mean.
Right. Yeah. Now, if we had 60, then I would have put a zero there for 60.
Okay.
All right, let me put my stuff back in there. Nope, that wasn't the color I used before. Put my notes back. There we go. All right, so got 91, 92, 93, 100, 101, 101, and then 112. All right. So that's it for the stem leaf plot. But before we go any further with any more explanation, questions on what we did here. Make sure we're all right. All right. So I didn't mean to do that. There we go. So if you look at this, and let's say if we were to set it up horizontally, I could have actually had a bar graph here or histogram, and it would have given me the same result, same type of information. So the question you may ask is, why would somebody do this versus doing a histogram bar graph, which may look more appealing to you or to anyone else? Excuse me. Well, it's all about when it comes to statistics and having a presentation is what helps you portray your argument better to your audience. So if you have an audience that's more number driven, or you think numbers may be more appealing to them, then you would do something like this. But if you have an audience that's more, maybe say liberal arts or something like that, you would use graphs with colors, bar graphs, circle graphs, things more along those lines. So it always depends on what your audience background is and what may be appealing to them, because you're trying to support your argument and to get them to roll with you. When it comes to statistics, I know you heard the saying that numbers never lie, but the other part of that is that they do mislead, or they can mislead. And so what I mean by that is that when you really get into statistics, if somebody has a set of numbers, they can make it say what they want to say, depending on how good they are with statistics. That's why when you're in politics, you say a president did such and such, this president didn't do such and such. I never really get too high or low or that mostly involved with it, because I know you really can take your data values and make them say what you want them to say. For example, when you get in here, you'll start to hear about outliers. I think to talk about that in chapter 2. Outliers is just very extreme values, very, very large values, or very, very small values in comparison to your data set. Well, when you get to a certain process, they'll say if you have outliers, you run your data set with outliers, then run your data set without the outliers. So then if with the outliers support your arguments, you use that. If taking the data values out support your arguments, then you would use that. So then when somebody see your data set, they will say, well, these numbers are here, aren't they very large? Well, you say, well, they were part of my observations, even though they were outliers. If you leave them out and somebody asks you, well, what happened to such and such values? You say, well, they were outliers. So that's not a part of the normal data set. So you can take numbers and data values and make them say what you want them to say, as long as you know how to defend your case. So statistics is really the art of, making numbers say what you want them to say and actually using numbers to support whatever argument you're trying to present. All right. So yeah. So that was just a few things, a couple of things that people have had questions about in the past. Um, remember now, not remember, but we talked about last class what you're held responsible for when it comes to chapter 1 and chapter 2. Definitions. I told you that you have until 121. That should be a Friday, next Friday, to get those to me. And with anything, when it comes to due dates, always make sure if you're having issues with due date, make sure you get with me. Make sure you let me know that you're having issues so we can work this thing out. You don't have to take zeros unless you just want them. So especially for something like this, it should be an easy grade for you. All of your data values and terms are in order. You don't have to go Googling for them. All you have to do is go to the e-text. Yes, the lectures are recorded. Yep. So what's going to happen is on normally I get them done on Friday. If I can get them done earlier, like on a Thursday or something like that, then I will do that. But normally on a Friday is when I can get those lectures. They actually be coming from YouTube. I'll convert the lectures to a YouTube link and then shoot your link to you guys in an email. So these definitions are right here, chapters 1 and 2. Click on it. It comes through. I see someone said something in chat. Wait for this. So chapter 1 is 2 pages. And then chapter 2 should be, 1 page, but then it's really 1 page, but you have these 2 questions on the second page. But just make sure you see both pages. I know sometimes people just see 1 page. And then I have to, let them know they only sent me 1 page. So each one of them have 2 pages. Your e-text is right here. You can either click on chapter contents or e-text. If you do chapter contents, then you can go straight to the chapter that you're dealing with. So your book is right here. Let's see. Yep, I need to change that due date. So I'll open that up in a second as far as your homework assignments. Thanks for letting me know. When we finish the definitions, we submit in MathLab or email. So your definitions, you shoot them to me in email. Email is just vtucker@tcc.edu. Some people have sent them to me through Canvas. I get them either way. So, but you wouldn't submit them through MathLab. You submit them to me through email. So either you will write them down, take a picture, with if you write them down notebook, take a picture with your phone or something like that, scan it, or you can just download it, download the Word document and then type it up and then shoot that document to me. Either way is fine. Yes, I was having problems with copying the shell, so my syllabus didn't copy over, but I'll put it right up in here. It'll probably be in between course home and assignments. Yep, not a problem. So let me see, let me look at these due dates since I'm right here. Okay, so I'll change these due dates to May 1st. So let me explain the process and how I normally have my statistics classes. I will put, let me go back to the notes. All right, I will put a hard due date at May 1st. All right, and that's a Sunday. Our last official day in SIS is May 2nd, which is a Monday, but we're not going to meet on that day. Everything will be done by, we'll do our final exam the week before. So I'll give you that weekend and everything. And then May 2nd, I can get grades in. So you have to May 1st to do everything. So now what that does, that leaves room for life to happen and you don't have to ask for an extension. The only due date that you will have are things that that I tell you to do manually, like these definitions or something like that. And the reason why I do that is because it would be to your benefit to get that done in a timely fashion in order to be able to do your assignments, stuff like that. But everything in MathLab that's submitted through MathLab will have the due date of May 1st. So once again, that leaves room for life to happen. You don't necessarily have to ask me for an extension. But just because something is not due does not mean you're not behind. So make sure you're careful with that. Come Wednesday, Monday we have off, so that's good for us. So we don't have class on Monday, so you don't have to worry about lecture or anything. That gives you more time to knock out chapter 1 and chapter 2. But we're going to get into chapter 3 on Wednesday. Chapter 3 is not heavy content. I could get chapter 3 done if I, position the lecture properly. I probably can get majority of chapter 3 done in one class. Maybe have one section left or something like that. But I'm not going to do that because I'll do my best to pace this out so that you can have time to process. And so in other words, Wednesday we'll do 3-1, 3-2, and then following Monday may do 3-4, 3-5, something like that, where we may be done with chapter 3 the following Monday, but I'm gonna try to pace it out and everything like that. But my point is, I could get, in 2 classes, chapter 3 done, in 2 more classes, we'll be done with chapter 4. Next thing you know, we'll be in chapter 5. I'm not gonna try to do it that fast, but I'm just saying it could be done. So what you don't want to do is take the content for granted while it's easy. So you have definitions and graphs. So knock this stuff out as soon as possible and get it out of the way so it's not just lingering around and hanging around, because this stuff will get to you quick if you're not careful. Everything that's in Math Lab is due by the 1st, everything. So, but once again, you don't want to get started on this stuff in April. And don't forget, I do need you, the way I solidify your attendance is by your activity in Math Lab. So you can't just not do anything until April and still be in the class, because you're supposed to be doing the stuff as we progress throughout the course. So the way you always can gauge yourself is by looking at the lectures. As we move throughout the course, that's the way you should be moving. So if we get into chapter 3, that's not saying that you should be done with everything, because now I'm in chapter 3, but you should be heading towards it. If we're in chapter 5 and you're still in chapter 2, you got a problem. You know what I mean? You can gauge. We're lecturing about chapter 5 and you're still working on chapter 2. We need to pick up the pace. So you can always gauge yourself as to where the lecture, where we are in the lecture. Yes. So once again, so everything's due by May 1st, but you don't want to wait till May 1st to get this stuff done, because you don't want to put yourself in position of having chapter 1, chapter 2, chapter 3 that you have to get done in a weekend and stuff like that. You want to be progressively doing this stuff as we walk through the course. Like I said, I'm just giving you room for life to happen, and you don't have to ask for an extension. You most definitely don't want to still be dealing with chapter 1, chapter 2 stuff in February. 31st of January most definitely should be the last of anybody dealing with chapter 1, chapter 2 stuff, because by February we'll be actually either closing out chapter 4 or in chapter 5. So you don't want to still be holding on to chapter 1, chapter 2 stuff come January. But what it also allows for you to do is to go back and do stuff if you want to get a better grade after you did it at one time. You want to go back, so it leaves room for a lot of things to occur if you be responsible with it. Okay. Questions on that due date stuff. Make sure we're okay. The lectures follow the textbook. I want to make sure. Yeah. I'm coming straight out of the textbook. Yep. Mm-hmm. Yep. I understand. Not a problem with that. So when it comes to chapter 1, chapter 2, these are the things that you have that you are responsible for. You got chapter 1, chapter 2 definitions, chapter 1, chapter 2 math lab work, and then you have that test 1. So those are the things that you're responsible for when it comes to chapter 1 and chapter 2. Once again, there's no hard due date on that except for May 1st, but you don't want to sit around, let it just be out there, because you're still held responsible for it. Also, it gives room for you to move ahead as well. Like the first couple of things we're going to talk about in chapter 3, mean, mode, and median. And so you might be good with that already. So, you could move ahead if you like. Questions on anything that I've said? Make sure we're okay. Make sure we are straight. Good. Yep. And a lot of stuff I'll be, switching back and forth for anybody who's watching what I'm clicking over here, because I've had people do it before. I've switched back and forth between my 245 and 155 classes, because it's all both of them are my statistics classes, and a lot of the notes I've already written in 245, and I just instead of rewriting them, I just go to those notes in 245 and stuff. So same stuff. It's only same way. Math is the same no matter what you call it. So all right. Any questions, concerns, comments before we close out today? Make sure everybody's good. Make sure everybody's straight. All right, Chad. When you say these, no, you're talking about what I've written. No, these notes aren't, because I'll send you the video and I'll send you that through Canvas. And so you can get the notes from there. I don't know if I have a way of sharing this and putting it in MathLab, like this screen. So I would say the best way to probably handle it is when I give you the link, you can, pause it, as much as you like, rewind and everything like that, fast forward it when I give you the videos. All right. Anything else? Anybody else? Pretty good. All right. So if you guys are good, I'm good. If you have any questions that come up, that you didn't think of right now, you can always email me. That's btucker@tcc.edu. Yep. Not a problem at all. Yeah, so I'm most definitely going to send you a copy of the video lectures. As a matter of fact, for anybody who missed the first day, I mentioned I'm going to send you a copy of the previously recorded lectures from last semester as well. So you have all the videos if anybody wanted to move ahead. And so you have that at your disposal. So if you guys are good, I'm good. Feel free to email me, and I'll answer your questions accordingly. I'm waiting on some funds so I can purchase MathLab assets. Okay, so don't forget you do have the 14-day free pass as well. That if you didn't want to wait to get to those definitions, you want to go ahead and knock them out, and if you want to go ahead and get into your assignments, you will have 14 days free that you have full access. I think MathLab is $75 if you purchase it through MathLab through Pearson. Yep, not a problem.
I have a question. So you said that I could use a previously, like you said, I could buy a code off of a peer or something like that, right?
Yeah.
Last.
Mhm.
So if I can get the code and I put it in, it's not like I'm in her account or like her old class or whatever. I could still just use it for the notes and stuff.
Well, no, now if she's used it already, you can't just reuse a code.
Oh.
Now, the only time you can buy it, like that's why I think I said this, because you can't share a code, but you can buy somebody's code, like if they didn't use it. But once it's used, it's a wrap on that.
I got you.
Mhm. And somebody else said, is there a way for now you can use your financial aid through TCC, Barnes and Noble. Like if you were to buy access through TCC, you can do that, but you can't buy it through Pearson using your financial aid. So hopefully that answers your question. Anything else? Anybody else? Can I buy the book at TCC? Yes, you can buy the book through TCC. I don't know how much the book costs, because remember, we don't have to, I'm not, it's not mandatory to buy the physical book, the actual tangible book, but you do have to purchase MathLab. So purchasing access, I believe, is $75. And that will just give you the, access code. And then from there, you'll get an e-text, which is the exact copy of the book, but it's through MathLab. But if you want to actually buy the book, I'm pretty sure it's going to be, probably be closer to $100 if you're going to actually buy the book itself that you can put in your hand. All right. Yep, not a problem. Anything else? Anybody else before we close? All right. So you guys have a great day. Be safe. And have a great holiday as well. And I will see you on Wednesday.
Thank you.
Thank you. Take care.
Thank you. See you.
All right. Take care.